Hello and welcome back. In this section, we're going to discuss about activation functions in neural networks. So we're going to discuss several activation functions such as sigmoid, tanh, ReLU, leaky ReLU, parametric ReLU, exponentially linear units, gated linear units, swish, mish, and softplus. And of course, when new activation functions are developed in the deep learning community, then we'll be adding them to this course. Okay, so before we start discussing about the activation functions, let's have a recap about linearity and non-linearity. So remember the case of linearly separable and non-linearly separable. In the case of linearly separable, we have two classes that can be separated by a straight line. It's possible to separate these two classes by a straight line. And this straight line has a very simple equation, which is mx plus c. So in this case, the two classes can be separated by a straight line. But in the case of non-linearly separable, then these two classes can't be separated by a straight line. As you can see, we can only separate these two classes by a complex function, such as a curve or a circle, in this case right here. So if you observe this diagram, there's no way on separating these two classes by a straight line. If you draw a straight line anywhere here in this diagram, it's impossible to separate these two classes from each other. So in this case, this is non-linearly separable, meaning that we need a complex function in order to separate these two classes from each other. And this complex function in this diagram is a circle. So our real world data is non-linear. So this is basically what our real world data is. Of course, it's much more complex than this. It's a very simplified example of it. But of course, our real world data is non-linear, and it's impossible to separate our real world data from using a straight line, which just has this simple equation mx plus c. So our real world data is non-linear, and it cannot be separated by a straight line. Therefore, we need to learn a much more complex function in order to classify or separate the data from each other that we're working with. So depending on your application might be regression, prediction, or it might be classification. But in any case, we need a complex function to learn the non-linearity in this data. Okay, so this is why we need activation functions. Activation functions are in charge of introducing this non-linearity. So without using an activation function, we would just have this straight line right here, because remember, the output here, if we go back to this slide, then the output here is just a linear function, x1w1 plus x2w2 plus x3w3. So this is just a linear function. Therefore, if we don't introduce this non-linearity, then we would end up with the linear function that won't be able to separate the data. So this is where we add our activation function directly after this linear operation, which takes the weighted sum of all the neurons. So in very simple terms, an activation function is a non-linear function which takes a linear scalar, z1, which is basically the weighted sum of the input, which is just a linear function, and maps it into a numerical value, which is non-linear. Okay, in this case, it's y1. So this is an activation function. I hope you got the intuition of why we need an activation function, and in the next lecture, we'll start discussing about several activation functions. Thank you very much, and I'll see you next time.